Chapter 1, Lesson 3. As I said, we're finishing up permutations, our second specific objective. So we're talking about the restrictions piece now. So we did talk about kind of restrictions in terms of ordering things. Now we're talking about restrictions in terms of repetitions. So just kind of keep that in mind. That's how we're going to change things. But any main problems, restrictions are placed in order to which objects are arranged. So that's what we're going to talk about first with restrictions. And then we'll get to repetitions. So restrictions, like again, permutations can be done permutation or fundamental accounting principle. They kind of accomplish the same thing. So if you see stuff better with fundamental accounting principle, you can use that. There are situations that you do need to know permutations in terms of how to enter those in a calculator. So I'm just saying it's kind of flexible between the two, to be honest. Okay, so in how many ways can all the letters of the word oranges be arranged if there's no further restrictions? So if there's no restrictions, how can we arrange it? Yeah, so there's 7 letters, so 7 factorial. There's no restrictions. I'm going to tell you 9 times out of 10 they're going to put restrictions on these when it comes to the diploma and whatnot. Okay, the first letter must be an N. So how does that change things? N is locked in place, and so we just put an N here, and then how many spots we got left? 6. So it's simply 6 factorial. Okay, so I can get you totals here. Sorry, so it asks for how many ways. So first one, there's 5,040 ways to rearrange oranges, no restrictions. If I have to start with an N, it goes down to 720. Is how many ways you can arrange with N starting. Okay. So a lot of times people try to put a number where the N is. So I like to put a letter here because it just tells me I'm not multiplying this by anything. What the number is a 1 because it has to be that if you want to put a number there, but otherwise just kind of exclude it. The vowels must be together in the order of OAE. So OAE means that's locked in. Okay, so they must be together. Now there's something we need to consider here. I have O, A, E. We're moving them together. Okay, so it does not say start with, right? I put in the start for now, but they can move. Does that make sense? And so what's left? How many letters are left? 4. So then how many movable spaces do we have? It's okay. 5. 1, 2, 3, 4, 5, because this can move. It doesn't say how to start with OAE. If it starts with OAE, then you're 4. Okay? But since this can move, we have 5 places that we order. So what I say is treat this as one letter. OAE is like one letter. We now have 5 things that we're shuffling around. Okay? So this would be 5 factorial. And you get 120. Okay, questions on that? That's the most common right there. Grouping stuff together. Yep. But see, all you're doing is you're moving to the next spot. What I'm telling you is just picture that this is one letter. So think about this as an empty space. It doesn't have to go here. See what I'm saying? I know you can move it over here, but you'd still do the same thing. Okay? The point is OAE can move. So there's 5 places it can be. Okay? All right, any questions on that? It's very wordy, so please ask for clarifications. The other thing I want you to pay close attention to is see how it says must be together in that order. If it didn't say that order, then we'd have to do some extra little stuff too that we're going to talk about later. That is key word there. Yeah. Correct. Yeah, you could just write. What you could do is if it helps you, Jake, you could say OAE, and what we got left here, we got R, N, G, and S. 1, 2, 3, 4, 5 letters I'm mixing now. Because this is considered one group, right? You could do it that way too. Okay? All right. I like to put it the way I did here because it just shows me that they're on one spot together. But yeah, whatever works for you. All right. So in how many of the arrangements of the letter of the word brains are the vowels together? So same type of question. But see what's different on the verbiage there? Order doesn't matter, so we're going to have to count for that too. Okay? So I'll show you what that means in a second. So how many vowels are there? 2. So how many arrangements of the letters of the word brains are the vowels together? So I'm going to group them together on a space that can move. So that means we have 1, let's see, we got 6. So we should have 5 spaces left, right? 1, 2, 3, 4, 5, 6. Or did I get one too many? Let's see here. Hold on. B, R, B, R, N. Yeah, I have one too many. There we go. Okay. So we have 5 spaces with the AI being together. So this is the same exact situation. The AI can move together. So it's still going to be what? 1, 2, 3, 4, 5 factorial. But the AI has 2 different orders, doesn't it? So what you're going to do is, okay, stay with me. I think some of you guys are trying to catch up right now, so ask if you need to. This right here can be AI or IA, but essentially it's 2 things are being shuffled, right? So we have 5 spots to shuffle everything, and then these guys can shuffle. It's simply 5 factorial times 2 factorial because the order of the AI doesn't matter. We have to do both orders. 2 factorial is just 2. Don't be confused. It's 2 times 1 because AI or IA in this case.
So are we still treating that spot like it's 1? Or
No, because you treat it like it's 1 if it can't move. It doesn't say start with AI.
Oh, so if it's not order.
If it says it has to be in the front or the back, then that's a 1, and you would just times by 2, and you'd shuffle the 4. But since it's not saying it starts with it, then you can move it so it's part of the move. Hope that makes sense. Sorry. Yeah.
So if it was like 3 vowels and
Like the previous one, yeah.
yeah, and they like it didn't matter what order it came, would it be times
3 factorial. 3 factorial.
why don't you just do it by 3?
Because the reason it's AI is just 2 factorial is because there's only 2 ways to write this. Okay? But if I write AIO, remember with cat yesterday? Cat has 6, so we need 3 factorial to mix it because there's 6 more options. Yep, good question. Yep, anything else? Okay. All right, let's look at the next one then. So yeah, sorry, that's 5 factorial times 2 factorial. So sorry, the total, didn't do the total yet, is 240. So there's 240 ways to make that arrangement. Okay, 240 ways to make that arrangement. Okay, final permutations of the letters in the word kitchen. Letters K, C, and N must be together, but not necessarily in that order. Okay, so I'm going to group them together, put them on one space. We're going to move them around. What's left here? So we have 3 letters. 1, 2, 3, 4, 5, 6, 7. So we have 4 letters. Okay, so that's what we have in terms of what we're moving around. K, C, N can move, and it says that order is not important. It's not staying in that order, so that means there is other orders of KCN. So it's 1, 2, 3, 4, 5 factorial times 3 factorial this time. So that would be 720. Okay, the 5 comes from these 5 spaces. The 3 comes from the shuffling of the 3 letters. Okay. A little bit tricky now. What would you do to get the vowels must not be together? Vowels must not be together. Can you think of a strategy for that? So when it says not stuff, guys, we're going to do the number of total ways. So there's a total ways that you can shuffle 7 letters. Okay? Then you subtract. What could we find? When they are together, exactly. So we'll do total minus when they are together. Vowels too? Okay, so do the total ways to shuffle the word kitchen minus the vowels together. That will get you when the vowels are apart, right? Because they're together or they're apart. So the total ways is 7 factorial. Anyway, so the total ways you can move kitchen around is 7 factorial because there's 7 letters. That's with no restrictions, just simply how many ways can I order kitchen. Okay, if I want to do it with the vowels apart, I'm going to subtract the vowels together because we know how to do that. So the vowels I have are I and E. Okay, so that's the only 2 I have to worry about. So I and E together Okay, that's a spot. Okay, so it goes from 7 to 6 places. I don't have room here. 3, 4, 5, 6, 7. So that is essentially going to be minus 6 factorial times 2 factorial because the I and E aren't locked in order. They can move. Why is there 7 in the start? Or which one?
No, just the vowels together after 3.
Luke, on these numbers or why we're doing that?
No, I know why we're doing it. Just
Oh.
numbers.
Oh, okay. So the vowels together, there's only 2 vowels, so I group them on one spot. That's 2 of the 7 letters.
Yeah.
So there's 5 more spots. Yeah. Oh, I have 6 there. Sorry. That's why. There's 5 spots after. Yeah. Okay. Okay. And so that all we do now is we just subtract this and we're done. So this is total ways minus vowels together gives us vowels apart. Okay, apart for vowels. And so that actual calculation gets you 3,600. So it'd be 5,040 minus 1,440, 3,600. So 3,600 arrangements in which the vowels would be apart. That's what that means. 3,600 arrangements which the vowels would be not together. Okay, so example, kitchen is an example. The vowels are apart there. Okay? All right, so let's example 4. Any other questions? Okay, you're doing a good job with questions today. Thank you. Okay, so how many ways can 3 girls and 4 boys be arranged in a row if no 2 people of the same gender can sit together? Okay, so that means we're talking about 7 spots. Okay. And so we know it has to go boy, girl, boy, girl, boy, girl, because the genders can't be together. So you can just simply do fundamental counting principle, just go down the line here. But we are cornered. What do we have to start with? We have to start with the boy, right? Because if we start with the girl, we're going to have at the end, the boys are going to be clustered. So you have to start with the boy. So how many boys do I have to choose with to start? 4. Then we can just go, that has to be a boy. There's 3 choices, 2 choices, 1 choice. So there's your boy multiplier. And the girls would just be very similar. 3 girls to choose from, 2, 1. So essentially, this is 4 factorial times 3 factorial. Which is 144. So 144 ways to have boy, girl, depending on the people. Okay. All right. 6 actors and 8 actresses are available for a play with 4 male roles and 3 female roles. How many different cast lists are possible? Okay. So now this is a little bit more directly into permutations because it's simply set up for you for choosing. So you're not going to have to do counting principle here. Okay. So it says 6 actors and 8 actresses are available for the play for 4 male roles and 3 female roles. So one thing I want to point out is, remember I was telling you to take a group of people to be in the play? We're not taking 3 people to bring the play, we're taking 3 people to do specific roles. So they do have importance in terms of their order. Okay? So that's why this is a permutation, not a combination. Okay? Yeah, the word roles means they're going to play different characters, is what they're implying. Okay? If it just said select them for the play, then it would be a combination. And we'll get to that tomorrow. Okay? But this is how easy this is. 6 actors for how many spots? 4. So 6p4. Okay? 8 actresses for 3, 8p3. Now, the ways of the actors and the ways of females, the actresses, are going to be multiplied because it's like different options. So I could have these 3 guys with these 2 girls, and then these 3 guys with these 2 girls. It's a multiplication of the possibilities of boys times the girls. So you multiply that for your total ways of having a different cast, and it gets you to 120,960. So there's 120,960 total ways you can have, or different ways you could have a cast from that group of people. Okay. Any other questions? So again, yeah, because specific roles, specific jobs in the show, that's why this is a permutation. All right, so now we're talking about repetitions. I will tell you a lot of times repetitions aren't stated. So what I mean by that is on the diploma, they can ask you, what are the total ways to rearrange this word? If there's ever a repeated letter, you have to do repetitions. They won't tell you to. Okay? The reason being is if you think about what we're showing you right here, if you have like rows, that's all 4 of the different letters, right? So these are all the ways you can arrange rows. Okay? That's all of them. Now if I change the rows to Ross, now we have 2 S's, and so you can see that? That's the same formation. We don't double count that. Even though those S's switched, it doesn't matter because it's a repetition of S. Does that make sense? And so that way we would not double count that. Down here we wouldn't double count that. We wouldn't double count OSSR, etc. So that's what we're looking at with letters. So my basic point to you is whenever you're doing an arrangement of letters with permutations, okay, do not make sure that you account for letters being repeated. Okay, anytime a letter is repeated. All right, so anyway, so what happens is though, let's just go to this first part here. So when you do arrangement of 4 letters, you get 24. So 4, pick 4. Okay, 4 permutation 4. And then when you do it for Ross, you get a repetition, and it cuts it in half because S is repeated. And you simply just divide by how many times you repeated something. So if I have 2 S's, I divide by 2 factorial. If I had 3 S's, I divide by 3 factorial. Okay? We'll talk about multiple letters in a second, but that's the basic idea. So you do the normal 4 factorial for letters, and then you divide out the repetition. Okay? So that stands for the 2 S's. And then see right here, here's the 3 S's. I just told you, 4 factorial over 3 factorial. So it gets really small. There's only 4 ways to rearrange those differently because the 3 S's really make things difficult. And that makes sense because why? Because all only it changes where the R's at. Let me just kind of illustrate this real quick. Oops, got the sound on still. So see, that one's 1. That one's 1. That one's 1. That one's 1. The only thing it changes where the R's at. First spot, second spot, third spot, fourth spot. That's the only 4 different ones. All right, so let's look at some actual that's just kind of illustrating it for you. Let's look at, this is the form for it. So the number of things you have divided by the repetitions of what's being repeated. Okay, why it says A, B, and C? Some words can have 2 S's and 2 L's. So that means if you have 2 S's and 2 L's, what do you have on the bottom? 2 factorial, 2 factorial. Okay, so you can have more than one type of repetition, so don't think it's just one number. Okay, so let's look here. Vancouver. So Vancouver, let's do the first thing. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 factorial. Okay, and what's being repeated? V. So 2 factorial, anything else? Doesn't look like it. So 9 factorial over 2 factorial. Okay, and that is it. So it's 181,440. Okay, mathematical. So we're looking at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're looking at 12 factorial. We have 2 M's. We have 2 T's. And 3 A's. 1, 2, 3. So this is your buildup. 12 factorial over 2 factorial, 2 factorial, 3 factorial. Okay, so everybody okay with that? Still a pretty big number. Even if we divide that stuff out, it still ends up being 19 million. Still pretty massive, even with the repetitions. Okay. Anything else? Just got 2 more examples, so hang in there for a pretty short day. Okay, Brett bought a carton containing 10 mini boxes of cereal. There's 3 boxes of cornflakes, 2 boxes of Rice Krispies, 1 box of Cocoa Pops, 1 box of Shreddies, and the remainder are Raisin Bran. Over a 10-day period, Brett plans to eat the contents of 1 box of cereal each morning. How many different orders are possible if the first morning he has Raisin Bran? So the first thing we can kind of help you here is go ahead and figure out how many of each there are on the side here. So we just need to know what Raisin Bran is. So there's 3 cornflakes, 2 Rice Krispies, 1 Cocoa Pops, 1 Shreddies, and then, so that leaves me with, what, 3 Raisin Bran? Okay. We know he's starting with Raisin Bran. Okay, so that's just locked in. So that means we have 9 days left. So that means we're doing 9 factorial. We're 9 things we're shuffling, right? So the only thing you have to ask yourself now, if we're doing 9 factorial, what's the repetitions? Okay, 2 Rice Krispies. What's that? Yep, 3 cornflakes. And what else? 2 Raisin Bran. Okay, it's 2 Raisin Bran because we already ate 1 to start. Now, if you're not understanding the repetition piece here, is because let's just say, for example, I have cornflakes the second day, and then I have cornflakes the 5th day. If I flip those boxes of cereal, I still ate the same thing. It's not a different arrangement. Okay, that's why we have to divide these out. That's why it's a repetition. These are the same types of cereal. Okay, so when you're looking for repetitions, you're looking for same letters or situations where it's exactly the same thing. A lot of times when the stuff they ask you, identical cars, when they see the word identical, or we see stuff that's just changing by color, think about repetitions. Okay. Yeah, second 2 came from Raisin Bran because 1's gone, so we have 2. We have 2 left. Yeah, 1's gone. We have 2 left. Good clarification. Probably didn't really talk about that good enough. Okay, anything else? So that calculation ends up being 15,120 ways to eat their cereal. 15,120 ways to eat the cereal in 10 days. Okay, we're going to talk about a little bit of a pass here. Okay, all right, let's look here. All right, so Paul and Catherine are considering the following problem. Find the number of routes from A to B if the routes must always move closer to B. So it means you just can't move back. Okay, Paul arrived at the correct answer of 10 routes on the grid. Catherine developed a quicker method. She realized that the travel from A to B involves moving 3 units east, 2 units south. And that the answer of the problem, which the way it can be done, is E, E, S, S in any order. So what she's done, Catherine's essentially looked at it in terms of repetition. There's 3 east, 2 south. So that means no matter what, guys, if you're moving to that dot B and you're always going forward, you have to go 1, 2, 3, 4, 5. It's 5 movements no matter how you do it. 1, 2, 3, 4, 5. That makes sense? So if we're always going closer to B, it's going to take 5 movements. There's no shortcuts. There's nothing I can do different than 5 movements. But we have repetitions of direction. Okay? So like if I went, for example, if I went this, well, if I flip this E to here, it doesn't change anything. It's still an east movement. Okay? So we're essentially ordering the letters of those 5 commands, of those directions. So it's 5 of them, 5 factorial over 2 factorial, 3 factorial, which gives you 10. Okay? That's how you use repetition for direction. And we just did this part here, solving it using Catherine's approach. Okay, any questions on that? Okay. All right, so I'll pause the video. So